Nomenclature of amines. Amines are organic derivatives of ammonia and H3 with one or more alkyl groups bonded to the nitrogen atom. So this is ammonia and bonded to three other hydrogens. Amine primary, one alkyl group, two alkyl group is secondary amine, three alkyl group with no hydrogen at all is tertiary amine. The lone pair electrons on the end, here we have one lone pair of electron, 2 electrons in total, on this nitrogen atom makes amines both basic and nucleophilic. So here electron rich, so that's why nucleophilic, and it is basic because it has electrons, it can receive the H+, so that's what makes amines basic. Classes of amine: N attached to one R group only, 2 hydrogen, 1 R group primary, and then here N has only 1 hydrogen, 2 R groups, a secondary amine. This N has no hydrogen atom at all attached to this atom N is the tertiary amine. These three are the examples of aliphatic amine without the aromatic ring. We call it aliphatic amine. The next category is aromatic amine. Aromatic amine, amine with benzene ring. For example, benzene ring attached to N. This N has 2 hydrogen atoms, only 1 R group, which is the aromatic ring. This is primary amine. Secondary amine, N has 2 R groups, 1 hydrogen only, and the benzene ring is directly attached to the N, so we call this aromatic amine. And next example, the benzene ring directly attached to N, and this N has 3 alkyl group or 2 alkyl groups, 1 aryl group in total, so 3 R groups. This is the tertiary amine. IUPAC name for aliphatic amines: the longest continuous chain of carbon atom containing amino group, which means the carbon that is longest continuous chain of carbon attached to N, containing amino group attached to N, determines the parent name. The ending E in the alkane name is changed to amine. And then we have to give the number to the position of amino group and other substituent on the parent. The prefix N is used to show the position of other substituent on N atom. We have nitrogen atom. If the substituent is at the N atom, if the substituent attached to the nitrogen atom, we use N instead of number. The non-numeric locant N is placed after numeric locants when a list of them is needed. For example, the compound 2,4-NN tetramethyl 3-hexanamine. First, we have to select the longest carbon chain that has attached to N. So this N attached to this carbon. The carbon, select the longest carbon chain which involve this carbon because this N attached to this carbon. So the longest carbon chain here, 6 carbon in total. And then this is the parent, 6 carbon, the parent hexanamine, 3-hexanamine because the N atom is attached to carbon number 3. We start counting from the right, it will get number 3. If you count from the left, this carbon will get number 4. So we want the lowest number. So we start counting from the right, this carbon will get carbon number 3. N attached to carbon number 3, so the name of the parent is 3-hexanamine. And then on this longest carbon chain, we have 2 substituent methyl, one at carbon 2, another one at carbon 4. So 2,4-methyl, but we also have 2 more methyls, but 2 more methyls are on the N. So here this N doesn't have number, we don't give number to this N. So this methyl is at N. So that's why it's 2,4-NN, because 2 methyls at N. 1 methyl is at N, another methyl is at N as well. So NN. The total methyls that we have in this compound is 1, 2, 3, 4. 4 methyl, so tetramethyl. The position of the methyl is at carbon number 2, at carbon number 4, at N. So this is where the number 4 rule applies. The non-numeric local N is placed after numeric. So you have to give the number first, 2, 4, and then N. Not N, 2, 4. Wrong. It is 2, 4, N. Put the number first in naming and then N. N means the substituent is attached to N. Next example, longest carbon chain that has N, 5 carbons in total, and the N attached to carbon number 2, so the parent name is 2-pentanamine. And then 1 bromine is at carbon number 4, so 4 bromo, and then 2 methyl at N. So the name of this compound is 4-bromo N-dimethyl, 2 methyl at N atom, so N-dimethyl, 2-pentanamine. For aromatic amines, the non-numeric local N is placed before the numeric locals when a list of them is needed. So this is the opposite for aliphatic. For aliphatic, you put the number first and then N. If you want to number it, the number first and then N. But in aromatic, you have to put the N first and then number. For example, here we have the benzene ring attached to N, so aniline. The parent name is aniline. Benzene ring attached to N, aniline. And then 4 methyl in total. 2 methyls on the ring, 2 methyls on N. So on the ring, we can number. This is carbon 1 because it is attached to N. So this is carbon 1. This is carbon 2. This is carbon 6. So 2,6 methyl at carbon 2, carbon 6. And methyl is also, these 2 methyls are attached to N. So N, position of methyl is at N. So you have to put N first. N, 2, 6, tetramethyl. Tetra because 4 methyls in total. N, 2, 6, tetramethyl aniline. That's you apply for rule number 1. N first and then number, aromatic. For aliphatic, number first and then N. When multiple functional groups are present and the NH2 group does not take priority, it is named as an amino substituent. Means the functional group, you have a compound with functional group amino and you have the functional group that has higher priority than amino. That makes the amino become substituent because the functional group other than amino has higher priority. If that functional group has lower priority, then amino will become the parent. But if the functional group has higher priority than amino, then amino will become the substituent. Amine will become substituent and the name of it as substituent is amino. For example, we have here carboxylic acid and amino. So carboxylic acid has higher priority than amine. So carboxylic acid will become the parent. When amine becomes substituent, the name is not amine anymore, it is amino. So the parent benzoic acid at carbon number 2 on benzene ring, 1 amino group, carbon number 4, another 1 amino group. So the name of this compound is 2,4-diamino. Di because 2. Di means 2. 2,4-diamino benzoic acid. Next, ketone and amine. So ketone has higher priority than amine. Ketone become the parent. When ketone become the parent, carbon number 2 as double bond, so 2-pentanone, this is the name of the parent. And then this NH2, it will not name as amine anymore, it becomes substituent, so this is amino. The name of this compound is 5-amino-2-pentanone. Physical properties of amines. Boiling points of amine. Both primary and secondary amines can form intermolecular hydrogen bonds between molecules, but tertiary amines cannot form hydrogen bonds to each other. This is due to tertiary amines does not have hydrogen attached to N. Here, tertiary amine, there's no hydrogen attached to N, all carbon. In primary amines, 2 hydrogen. Okay, in primary amine, 2 hydrogens attached to N. Secondary amine, 1 hydrogen attached to N. But tertiary amines, no hydrogen attached to N at all. So that's why tertiary amines cannot form hydrogen bonds to each other. This makes the boiling point of primary amine is the highest because it has more number of hydrogen. Primary amine is the highest, and then followed by secondary amine, the least boiling point, the lowest boiling point is tertiary amine, because tertiary amine has no hydrogen bond with each other. It cannot form hydrogen bond with each other. Amines have higher boiling points than alkanes or haloalkanes of comparable molecular weight due to the formation of intermolecular hydrogen bonding between molecules. Because amines have hydrogen bonding in them, but alkanes and haloalkane do not have hydrogen bonding between them. Amines have lower boiling points than alcohol and carboxylic acid of comparable molecular weight because hydrogen bond in amine is weaker than hydrogen bond in alcohol and carboxylic acid. We know that amine N bonded to H, carboxylic acid and alcohol O bonded to H. Those are the difference between amine, alcohol and carboxylic acid. This is due to nitrogen. In amine, we have nitrogen and H. Nitrogen is less electronegative than oxygen that we have in alcohol than carboxylic acid. Therefore, the NH bond in amine is less polar than OH bond in alcohol or carboxylic acid. That's why the boiling point of amines are lower than alcohol and carboxylic acid, even though these three, amine, alcohol and carboxylic acid, they have hydrogen bond. But hydrogen bond in amines are the lowest or the weakest. Hydrogen bond in amines are the weakest because of nitrogen is less electronegative than oxygen. In alcohol and carboxylic acid, we have oxygen. Oxygen is more electronegative than nitrogen. That's why the boiling point of amines are the lowest. Solubility of amines in water. All amines having less than or equal to 5 carbons are water soluble because they can form hydrogen bond with water. 5, 4, 3, 2, 1 carbon in amine, water soluble because amines, we know amine, it can form hydrogen bond with water. It has NH, so it can form hydrogen bond with water. But amine having more than 5 means 6 and above are water insoluble because the alkyl portion or hydrophobic area, the carbon part in the amine is too large to dissolve in water. That's why 6 and above carbon amine is water insoluble. So this is primary or secondary amine. It can form hydrogen bond with water. The hydrogen will form hydrogen bond with oxygen lone pair. Primary amine can form more hydrogen bond with water molecule because primary amine has more number of hydrogen. That's why it can form more hydrogen bond. Secondary amine has 1 hydrogen only. So that's why secondary amine can form less hydrogen bond compared to the primary amine. For tertiary amine, it has no hydrogen at all attached to N. Between tertiary amine and tertiary amine, there is no hydrogen bond at all. But between tertiary amine and water, there is hydrogen bond because the lone pair on the amine can form hydrogen bond with water. But tertiary amine and another tertiary amine, no hydrogen bond because no hydrogen at all. Here in water, it can form hydrogen bond because it has hydrogen on the water molecule. Okay, so tertiary amine can form hydrogen bond with water. Solubility of amines in organic solvent. Amines are soluble in organic solvents such as alkane, alcohol, and ether regardless of size. This is due to the formation of van der Waals forces or London forces between amines and organic solvent because it has the carbon part, so it can form van der Waals forces or London forces because London forces exist in all types of molecule. So amines are soluble in organic solvent.